Now that you have some familiarity with the Matlab desktop environment, it is time to start using Matlab as a program. And in this video, there's two goals. So the two goals of this video are to show you how to use Matlab as a simple calculator and to introduce you to something called the colon operator, which is the colon key, and that can be used to generate simple number sequences. In some sense, Matlab is basically just a fancy calculator. So we can type, for example, 1 plus 1, because apparently I have no idea what 1 plus 1 is. Now, nothing happens when I type 1 plus 1. Well, we get the text here, but Matlab doesn't actually run this code. To run a line of code, you need to press the Enter key, and that tells us that 1 plus 1 equals, so ANS is for answer, so the answer to this line of code is 2. So you can use Matlab as a regular calculator the way that you think you should. So for example, we can say 3 minus 6 equals minus 3. And in fact, I wrote a little script to help us with this video. So we need to open that script. So I'm going to click on Home and then Open. And now you might need to move around to other parts of your hard drive to find the file, but we are working with this file that's called onramp desktop calc colon, so calculator colon. So we open this file, and now you can see that that Matlab opened up the editor window, which I already introduced you to. And again, this is my preferred layout for the editor and the command window, and of course it's up to you if you would like to change it. Maybe you want it like this, so then you can see more of the vertical orientation and so on. So that's really up to you. Maybe you prefer it to be on the bottom like this. Somehow this looks wrong to me. I'm going to put it back up here. Okay, so here we have comments in green indicated by a % sign. I will talk a lot more about comments later on, but comments are basically just lines of text that Matlab ignores. Matlab is not going to try to interpret these lines of code. Instead, Matlab is going to try to interpret these lines of code. Okay, so you can see that just having text in the editor doesn't do anything. Matlab has no idea what to do when it just sees text in the editor. Matlab only ever cares about code that is run in the command window. It has to be run in the command window here. So there's several ways to run code that you have in the editor, and for now, you can just worry about copy paste. So copy and paste. So we already discovered that 1 plus 1 equals 2. Remarkable discovery. Here is, so the asterisk is for multiplication. So 4 times 5 plus 8 gives us 28. So of course 4 times 5 is 20 plus 8 is 28. And what I want to do here in this line is introduce you to the concept of spacing in coding. So these three lines are actually all identical. They give the identical output. Matlab is going to ignore the spaces, but I will let you determine which of these three lines of code is more easily readable. I think this is the most readable one, but I guess you probably think it's this line or this line, and you might think that this line is a little bit bunched up. Okay, and here is even another example of spacing and also parentheses. So here we have 5 times 3 divided by 6 caret 2. So 6 caret 2, the caret here is actually for a power. So this is 6 to the power of 2, and of course that's 36. This is, when just starting off with Matlab, if you're already familiar with Python, for example, this is one of the main early differences between Matlab and Python. In Python, a power would be a double asterisk. So 6 squared in Python code would look like this, but that is incorrect Matlab code. So to write 6 squared in Matlab, use 6 caret 2. Okay, so the main thing I want to show you here with these two lines of code is they both give us exactly the same result. So we get 0.4167. But I think you will also agree that this line of code is easier for a human to read. It improves code readability compared to this line of code. And all I did was put in some spaces and parentheses that just helps with visual grouping. This is an aspect of coding style that I'm going to be stressing throughout the rest of this course. Now, one thing you need to be mindful of is something called the order of operations. You might remember that from learning about arithmetic in school. The order of operations defines which arithmetic operation takes priority over which other arithmetic operation. So these two lines of code are actually not the same. So this first one is 16.6, and the second one is some much larger number. It's in scientific notation, but this is essentially 1.1313 times 10 to the third. But these are definitely not the same number. The reason why they are not the same number is that in this line of code, Matlab is first evaluating 3 to the power of 2.3 and then adding 4.1. Whereas here, I'm using parentheses to override the order of operations and say that the result of this line of code should be 3 to the power of, 6.4, so 2.3 plus 4.1. All right, so these are examples of how to use Matlab as a relatively simple calculator. If you go through the PDF reader for this section of the course, you will find a bunch of exercises that will give you some practice at transforming mathematical arithmetic operations into MATLAB code like what you see here. The next thing that I want to introduce to you in this video is the colon operator. This is a really, really important operator. You're going to be using the colon operator a lot throughout your adventures in MATLAB. So 1:5, that's what this says here. Let's just see what that does. So I copy and paste, press enter, and the answer is 1, 2, 3, 4, 5. So that already tells you what the colon operator does. So we start from the first number and you go to the second number in integer units. So 1:5 returns 1, 2, 3, 4, 5. And now this line is just to show you that you don't need to start at 1. You can start at 7. So now we start at 7 and we get numbers going up all the way to 109. And of course, you can also start with negative numbers. So here we have minus 15, and then we go up through 0, and we end at 4. Now, if you use the colon operator like this, where you have one number, and then the colon, and then another number, it's going to increase, Matlab will increase from the first number to the second number, always in unit increments, so in increments of exactly 1. If you would like to skip in non-1 increments, then you need to have 2 colons like this, and in the middle is the skipping amount. So, for example, here we saw what 1 through 5 does, or 1:5, and now I have 1:0.5:5, and that gives me numbers that go still from 1 to 5, so that part's the same, but now instead of going in increments of 1, we are going in increments of 0.5, so 1, 1.5, 2, 2.5, and so on. All right, so in all of these examples so far, we were just counting upwards. We were going from a smaller number to a larger number. How do you count backwards? Well, you might think that you should do something like this. This does seem pretty reasonable. So, we want to count from 10 down to 1. However, we get an empty vector. We get nothing. There's no answer. The reason is that with a single colon like this, Matlab always wants to count upwards. Matlab will always try to increase. So in fact, what we are doing here is asking Matlab to count upwards from 10 to 1. And Matlab says, well, okay, that's really easy to do. There's no way to count upwards. You start from 10 and you go upwards, you're already beyond 1. Okay, so instead, what you need to do to count backwards is use this format and tell Matlab to skip by -1. So we can write this as 10 colon -1 colon 1. And then we get the desired outcome, 10 in integers all the way down to 1. And of course, you can count downwards in steps of -0.5 if your countdown is in half steps or something. Okay, so here, the comment here says, Matlab stays within the boundary. So what does that mean? So let's think about what happens if so without running this line of code, we can think about what happens when we go from 1 to 10 in steps of 5. So from 1, we count up 5, that's going to be 6. And then if we count up 5 again from 6, that's actually 11. So it's an interesting question. Is MATLAB going to return 1, 6, 11 or just 1, 6? So let's see. Copy and paste. And in fact, we get 1, 6. So that's what I mean here with MATLAB stays within the boundaries. So MATLAB is never going to go above this third number over here. It will stop below it. So we can change this to, for example, I can say 1, skip 5, skip 11, and then we get the 11 over here. And by the way, to scroll up through the previous commands, I'm pressing the up arrow key. So I'm pressing the up arrow key, and that's going through all of the previous commands that I've run. So I just want to show you that we can change this to 12, and we get the same result. 13, we get the same result. 14, we get the same result, and so on. Eventually, we are going to get another number up here when it's possible to continue skipping according to this skip amount and still end up at or less than this third number over here. So in this video, I showed you how to use MATLAB as a simple calculator. I introduced you to the concept of using spaces and parentheses to make your code look a little bit more readable. And importantly, I showed you how to use the colon operator to generate number sequences. As I mentioned in the beginning, the colon operator is really important. You will use it pretty much all the time in numerical processing and scientific programming. In the next video, you are going to get to apply some of the knowledge that you learned here to solving some simple MATLAB exercises. I will see you then.